is the sequel from the Foundation Mathematics 1, yang first semester. Okay. So for course outcomes, okay, so you need to apply relevant and appropriate fundamental calculus technique. So this semester, mostly topics dia about calculus. For example, we have differentiation, application of differentiation, integration and application of integration. Okay, so number 2, demonstrate self-awareness and self-confidence using quantitative and qualitative approaches. So ini for statistik chapter 7 and chapter 8. Okay, so number 3, integrate theoretical and analytical thinking skills of basic calculus. And number 4, demonstrate the ability to express new idea and interest. Okay, so untuk course format and assessment, okay, so for course format you ada 14 weeks, okay, duration, and then lecture we have 4 hours per week, and tutorial is 1 hour per week. Okay, for assessment, test is 25%, same as last semester. Okay, group project or your assignment. Okay, we have also 25%. So 10% is for presentation, another 10% report, and last 5% is for peer evaluation. And final exam is 50%. Okay, so far assessment semua in ODL. Okay, so class policy. So attendance must be at least 80%. Okay, so you kena attendance you tu mesti sampai 80% ni. Kalau less than 80%, then you tak boleh sit untuk final exam. Okay, so untuk grading scale, so ini you punya grading scale. And then for reference, okay, so reference book you, you punya textbook tu, so far sebab you semua kat rumah lagi, so tak dapat lagi lah buku. Nanti you akan dapat buku bila you balik campus. Okay, so bila you balik campus nanti, okay, so nanti bila you balik campus baru you boleh dapat buku lah. So far saya akan bagi you semua in terms of PDF versions tu, notes in terms of PDF version. So you boleh print, lepas tu you boleh study kat situ je lah. Okay, so ini for textbook, and this one is for course outline. Okay, so we start with chapter 1 this week. Okay, the derivative. Okay, so derivative we cover for 8 hours. Okay, until week 2, until next week. So on week 3, kita akan masuk new chapter, chapter 2, applications of derivative. Okay, so applications of derivative we cover for 4 hours. Okay, on week 4, okay, on week 4, we have the third chapter, okay, integration. Okay, so integration is the longest chapter lah. We cover for 10 hours. Okay, so chapter 3 until week 6. Okay, so week 6 we continue with chapter 4, applications of integration. Okay, so application of integration for 8 hours. Okay, until week 7. So week 7 kita stop dulu. Okay, you ada midterm test lah. Okay, after week 7. So midterm test you cover from topic 1.1 until 3.4.1. So ni you punya topic for midterm test. Okay, so chapter 1 and chapter 2 tu masuk semua untuk test, and chapter 3 dia akan masuk separuh je sampai 3.4.1. Okay, so tu punya test. So for exercise pula, exercise ni sama macam you punya tutorial lah. So tutorial for test kita cover start from 1.1 until tutorial 3.3. Okay, so after test 1 week, so you have midterm break also 1 week. Okay, so after midterm break, okay, we continue with week 8. So week 8 still applications of integration, and for the second lecture tu kita akan continue with introduction to first order differential equation, chapter 5. Okay, so chapter 5 is 6 hours, okay, until week 9. Okay, so week 9 chapter 5 tu kita cover for lecture until 5.2 je. So you punya lecture akan sampai 5.2. So start from 5.3 until the whole chapter 6. Okay, so itu untuk assignment. So assignment start pada from 5.3 until 6.2 lah you punya assignment. Okay, so assignment ni sama macam last semester. You kena buat in group. Okay, lepas tu you kena prepare the report and also for your presentation. Okay. Next on week 10. Okay, so kita continue with chapter 7, probability and random variables. Okay, so chapter 7 and chapter 8 ni dah masuk statistik. Okay. On week 11, we have the last chapter, chapter 8, special probability distribution. Okay, until week 12. Okay, so week 3 you free lah. Okay, week 3 ni suppose kita dah habis semua lecture. Okay, so week 3 ni untuk you prepare for your presentations and also your report untuk case study. Okay. So on week 13 ni maknanya kita ada consultation je. Consultation on your assignment. And week 14, okay, untuk you punya presentations. Okay, so far presentation online lah. Sama macam last semester. Okay. So after week 14, then you have revision week. So revision ni, revision tak sampai 1 week revision week you. Jadi revision days untuk you punya revision ni. So after revision, so you ada final exam. Final exam start from topic 3.4.2. So topic ni continue balik from test hari tu. So 3.4.2 until 5.2 and chapter 7 and chapter 8. Okay. So for exercise, okay, cover from exercise 3.4 until exercise 8.3. Okay, so ni punya important dates. And this one is the list of the public holidays. Okay, so ada soalan tak? Okay, so saya nak start with our lecture. Okay, so chapter 1, the derivative. Okay, so derivative topics dia 1.1 until 1.2. So kita cover first for topics 1.1 until 1.2. So slide ni sama macam you punya notes so saya tukar in terms of slide. Okay, so for learning outcomes. Okay, so if you refer to your notes, learning outcomes for chapter 1, we have 5. So ini saya ambil the first two of the learning outcomes. Okay, number 1, obtain the limit of a function and computing limits, including end behavior. And number 2, determine the continuity of a function based on the definition. Okay, so this one is the definition of the limit. Okay, so definition, if the values of fx, okay, can be made close as we like to L by taking values of x close to a but not equal to a, then we write limit x approach to a, okay, fx is equal to L. Okay, so for limit ni, we need to find the value for the fx or value of the y when x will approach to a certain value. Okay, so for example, you have x axis and y axis, or fx or y axis. Okay, so for example, you have one value a. Okay, so for limit ni, we need to find value at the y. Contoh this one is the graph. Okay, so ni one is your graph. So we need to find the value of y axis. Okay, the value of the y when x will approach to a. So we approach to a, we have you have two-sided lah. So from left or from the right. Okay, so aim there we need to find value at the y axis when x to approach to a certain value, but not equal to a. Okay, dia hanya approaches je. Okay, satu if definition for the limit. Okay, so you can refer to example 1. So example 1 ni solution dia dalam recorded video pun dah ada. Tapi saya akan recall balik lah. Okay, so you refer to example 1. Okay, you need to complete the following table. Discuss the behavior of the values of fx when x approaches to 2. Okay, so first you refer to the x values. Okay, so x values. So x values start from 1.7. 1.7 next move to 1.8 until 1.99. So value of x, dia akan approaches to value of 2. So this one we call as approaches 2 from the left ataupun approaches 2 from the value of less than 2. Okay. So from right pun sama, start with 2.3 and then move 2.2 until 2.01. Okay. So ini when value of x approach 2 from the right. Also, when value of x approach 2 from the values greater than 2. Okay, so this one is 2 plus and then this one is 2 minus. Okay, less than 2 and greater than 2. Okay, so when x approaches to 2, next you need to find the value of the fx or values of the y axis. Okay, so substitute x into the function fx, so you get these values. Okay, so for fx pun sama. We start with 3.09 until 3.001. So values of y tu kalau you tengok dia approach kepada 0. Okay, so sama juga from the right hand side 3.09 until 3.001. So from the right, value for fx also approaches to 0. Approaches to 3. Approaches to 3. Okay, so you have answers there. The values of the fx when x approaches 2 from the left is 3, and the values of fx when x approaches 2 from the right is also 3. Okay, so ni you punya conclusion. In other words, we can say as x approaches 2, the values of fx approach 3. Okay, so kita hanya nak cari value yang approaches je. So that's why dekat column ni, so satu ni, dia tak ada value when x is equal to 2. So kita tak nak consider when x is equal to 2. Kita hanya nak consider values yang approaches je. Approaches to 2. So kita tak nak consider yang ni lah. Okay, sebab tu kat sini dia kosongkan je. So kat sini kita tak nak value kat sini. Kita hanya nak value yang approaches kat sini. Okay, from the left or from the right. Okay, or based on the table, based on the graph. Okay, so this one is the graph for function fx. Okay, so ini is the x-axis and this one is the fx or y-axis. Okay, so when x approaches 2 from the left, okay, so this one is the left. So you can see that value at the y-axis is 3. Okay, so sama juga bila values of x, the approaches 2 from the right and y also equal to 3. Okay, so ini based on graph and this one is based on table. Okay, so ni example 1. Okay, so ni example 2. So example 2 pun sama. So when x approaches 0 from the left. So answers dia dah akan approach to -3. Okay, so values of fx when x approaches 0 from the right is also -3. Okay, so ni you punya graph. So based on this graph pun sama, when x approaches to 0, so x kat sini, we exist x. So when x approaches to 0, so kat sini is the 0. So from the left, okay, so ni when x approaches 0 from the left, so answers dia you have -3 pada y, so kita nak pada you punya y-axis. So y-axis value dia is -3, and when x approaches 0 from the right, y also -3. So that's why answers dia is -3. Okay, so this one for example 2. Next for 1.1.3, the relationship between one-sided limit and two-sided limit. Okay. So for one-sided limit consists of two. So we have left-hand limit and right-hand limit. Okay. So for left-hand limit, notation dia is limit x approach to a minus. So kalau you ada negative or minus kat atas a ni, so they represent limit of function f as x approaches a from the left. So x dekat approaches a from the left. So kalau you punya graph, this one is a, so dia akan approaches a from the left. Okay, so from the left also values dia less than a lah. Okay, so for right hand limit, notation dia is when limit x approach to a plus ataupun a positive. So kalau ada simbol positif, dia represent the approach a from the right ataupun value yang greater than a. So dari sini, so from the right lah, so values dia akan greater than a. Okay, so we call as right hand limit. So these two we call as one-sided limit. So one-sided limit tu ada dua. Satu left hand limit, another one is right hand limit. Okay, so these two we call as one-sided limit. Okay, so this based on the graph. So for left hand limit, okay, so you have left hand limit. So dekat approach a from the left. So value dia we have L. Value at the y-axis. So ni value at the y is L. And from right, okay, so when x approach a from the right, answers is also L. So fx dia is equal to L. Okay, so ini for the right hand limit and left hand limit. Okay, so from left hand and right hand limit ni, we can conclude for two-sided limit. Okay, so for two-sided limit, notation dia is when limit x approach to a fx. So kalau you tengok for two-sided, dia dah tak ada simbol plus and minus. Okay, dia hanya x approach to a je. Okay, so dia different compared to left hand and right hand limit. Untuk left and right, dia ada simbol pada a, either negative or positive. Okay, untuk two-sided dia dah tak ada simbol. Okay, so kalau tak ada simbol tu semua kita consider for two-sided limit. Okay, so for the two-sided limit of a function fx exists at a, so ini penting, condition for the two-sided limit to exist. So if only if both of the one-sided limit exist at a and have the same value. Okay, so ini untuk two-sided limit. So ni specific for two-sided limit. So two-sided limit exists if and only if the one-sided limit exists and have the same value. Okay, so for example dia, kalau one-sided dia you ada x approach to a minus fx. Contoh value dia equal to L from left. So when x approaches a from the left, value dia you have L. And from the right pun, contoh x approach a plus, so fx is equal to L. Okay, so from the right also equal to L. So you punya two-sided limit, limit x approach to a fx is also equal to L. So yang dua ni is for one-sided limit. Okay, so untuk yang last is refer to two-sided limit. Okay, so you boleh tengok kat sini, two-sided limit, dia value dia depends pada one-sided limit. Kalau one-sided limit, both one-sided limit the value dia equal, contoh kat sini L, so automatic two-sided limit dia akan follow je, dia akan dapat equal to L juga value dia. Okay, or for second example, contoh saya ambil X approach to A minus Fx equal to L. Contoh when X approach to A minus, dia approach A from the left, value dia you have F, you have L. And when limit X approach to A plus, Fx equal to M. So when limit X approaches to A from the right, for example, value dia you have M. So two-sided limit exist ke does not exist?
Does not.
So
Does not exist.
Not.
So dia akan does not exist. Okay, so yang ni for two-sided limit dia. Okay, so you kena ingat yang two-sided limit dia based pada one-sided limit dia. Okay, so kalau one-sided limit dia, contoh kat sini, one-sided limit dia bila dia approach A from the left, you ada L, tapi bila dia approaches A from the right, value dia jadi M. So bila dia different value, automatic you punya two-sided limit akan jadi does not exist. Okay, sebab tu condition dia kata if and only if both of the one-sided limit exist, mana ada value and have the same value, baru you boleh kata two-sided limit ni exist. Okay, so for example, ni you punya example lah. So ni example dia given 1 minus dia dapat 0 tapi 1 plus dia 1. Okay, so however they are not the same, so limit X approach to 1 does not exist. Okay, so ini for definition of one-sided and two-sided limit. Okay, so yang ini for example 3. So example 3 ni saya skip, so sebab you boleh refer pada recorded video for example 3. So saya nak tunjuk you for example 4. Okay, so saya nak you refer to example 4. For the function in figure 1.5, so you need to find one-sided and the two-sided limit at x equal to -2, x equal to 1 and x equal to 3 if they exist. Okay, so we start with x equal to -2. Okay, so you refer to figure 1.5. First dia nak limit x approach to -2, tapi kalau based on graph, you kena calculate dulu dia one-sided. Maknanya you kena calculate x approach to -2 minus. Okay, so what is the fx? Ataupun what is the y lah. Okay, so -2 minus. So dia akan approach -2 from the left. Okay, so ni you punya graph. So graph ni dia oscillating function. So function dia tak fix. This graph dia pergi ke 4 dan juga kepada 2. So the graph dia macam ni. Dia oscillating function. So kalau graph yang oscillating function, so kita consider dia does not exist limit dia. Sebab you tak boleh nak determine y dia berapa. Sebab dia tak tentu, dia sekali pergi 4, lepas tu dia pergi 2, lepas tu dia pergi 4 balik. Okay. So maknanya limit when x approach to -2 minus fx, dia does not exist. Okay. So you check for limit when x approach to -2 plus. So when x approach to -2 plus, dia akan approach -2 from the right. So you tengok graph yang right daripada -2. So right dia yang ini. So dia akan approach kepada -2. Lepas tu you kena determine what is the value at the y axis. So value at the y is -1. So fx is equal to -1. Okay. So baru you boleh buat conclusion for two-sided limit. Okay, so conclusion when x approach to -2, so fx dia akan jadi does not exist. Okay, so dia does not exist since that the one-sided limit dia not equal. From the left is does not exist, tapi when x approach -2 from the right, answer still is -1. So value dia lain. Sebab tu you punya two-sided limit dia does not exist. Okay. Next, you calculate for x equal to 1. So, you repeat balik step dia. So, when x approach to 1 minus. Okay, maknanya x tu dekat approach to 1 from the left. So, you tengok 1. So, 1 ni refer to x axis ya. So, ini you punya x axis. So, 1 pada x axis kat sini. Ni you punya 1 dia. Okay, so 1. So, when x approach to 1 minus, maknanya dia akan approach 1 from the left. So, di 1, you tengok graph yang left daripada 1. So, left daripada 1 yang ini. Okay, so bila approach 1 from the left, so you determine value pada y dia. So, we have 3. Okay, next you calculate limit x approach to 1 plus. So, 1 plus when x approaches 1 from the right. So, you tengok graph yang right daripada 1. Okay, so ni graph right dia. Okay, so you determine value pada y. So, also approaches to 3. Okay, so for the two-sided limit, limit x approach to 1, fx, dia also equal to 3. So value one-sided dia sama. So automatic yang two-sided also equal to 3. Okay. So ini when x approaches to 1, last you need to calculate when x equal to 3. So limit x approaches to 3. So 3 minus. 3 minus is you refer to graph less than 3 lah. Graph yang less than 3 ataupun graph tu position dia left daripada number 3. Okay. So you refer graph ni. Okay. Graph yang less than 3. So you tengok value pada y dia. Y dia is 1. So dapat 1. Next you determine limit x approach to 3 plus. Okay. 3 plus makna you refer graph yang greater than 3. So ini you punya 3. So graph yang greater than 3 yang kat sini. So dia akan approach kepada 3. Okay. So determine value pada y dia is negative 3. Okay. Next you conclude for two-sided limit x approach to 3, fx dia akan jadi does not exist. Okay. So value dia different. From the left is 1 and from the right negative 3. Okay. So two-sided limit dia does not exist. Okay, so yang ni how method dia. Macam mana you nak determine limit based on graph. Okay, ada soalan tak so far?
No, madam.
No
No.
Okay. Example 5 ni boleh refer recorded video. Okay, so ini example 6. Okay, so saya move to example 6. So example 6 you can refer to figure 1.6. Okay, so the function graph in figure 1.6. Okay, so you need to find, okay, for A, limit x approach to negative 5. So yang ni dia refer to two-sided sebab dia tak ada symbol plus or minus. So refer to two-sided. First you need to calculate one-sided dulu. Okay, so you calculate x approach to negative 5 minus fx. So x approach to negative 5 minus, so this one is the negative 5. So you refer graph yang less than negative 5. So yang ini. Less than negative 5. So answers pada y is 7. So sama juga limit x approach to negative 5 plus. So negative 5 plus you refer graph yang greater than negative 5. So as the graph move close to negative 5, the value at the y approaches to 7. Okay. So then you calculate lah. You boleh calculate for negative 5 x. So also equal to 7. Okay. So the answer is 7. Okay. So B pun nanti you boleh buat. So ini ada recorded video boleh refer recorded video. So when x approach to negative 2, so this one is negative 2. So limit dia pun sama, you kena calculate negative 2 plus and negative 2 minus first. So answer still is 2. So for C, when limit x approach to 1. Okay. So C limit x approach to 1 minus. So you calculate dulu 1 minus. 1 minus, you refer function yang less than 1. So ini you punya 1. So function less than 1 yang kat sini. So as this function move close to 1, y is equal to -3. Next, you calculate limit x approach to 1 plus. So 1 plus as x approaches 1 from the right. Also, graph, we refer graph yang greater than 1. So answer state is 4. Okay. So values of one-sided they not equal. So limit x approaches to 1, fx does not exist. Okay, so ini for C, does not exist. So kalau D ni saya nak refer recorded video. So kalau D, x approaches to 4. So answer state is -2. Okay. So kalau F -5. F -5 ni bukan limit F -5 ni yang exactly value of y when x equal to -5. So you nak calculate what is the value of the y. Okay, so sama juga F -2. F -2 is exactly dia nak value when x equal to -2. So you need to find what is the value of the y. Okay, so for E, F -5, kalau kat sini you kena refer yang dense circle. Okay, so you can tengok yang dense circle. So F -5 yang dense circle dia kat sini. So value dia is 3. Y dia is 3. And when x equal to -2, so -2 kat sini, so you ada satu dense circle. Okay, so value dia is 2. Is -2. Is 2 Okay. So kalau contoh saya nak find F4. Berapa value F4? Berapa? When x is equal to 4.
-2.
Berapa? -2 ke does not exist?
Does not exist.
Does not exist. So F4 does not exist F4 does not exist. Sebab value F4 maknanya dia nak exactly x equal to 4. X equal to 4 maknanya you kena tengok yang ada dense circle tu. Kalau you tengok kat sini x equal to 4 kat sini, dia kat 4 ni satu line ni dia tak ada pun dense circle. Dia hanya ada empty circle. So empty circle maknanya dia tak ada value exactly x equal to 4. So F4 does not exist. Tapi kalau you check limit dia yang D ni, limit dia exist limit dia ada -2. So when x approaches to 4. Sebab tu dia berbeza dengan x approaches ataupun x equal to 4. Kalau x equal to 4 dia nak exactly value pada x equal to 4. Kalau x approaches to 4 dia hanya nak value y when x approaches to certain value. Maknanya y tu dia nak approaches ke berapa. Sebab tu limit dia still ada. So limit bila dia approaches kepada 4 daripada left you akan dapat -2. When limit approaches 4 from the right also you ada -2. Okay, cuma dia tak ada value x equal to 4 je. Okay. So yang ini for limit lah. Okay, limit based on graph. Okay. So boleh soalan tak untuk limit, calculate limit based on graph? Okay.
Okay.
Okay, madam.
Okay, madam.
Okay, so kalau semua okay, kalau ada soalan you segan nak tanya dekat sini, you boleh WhatsApp saya. Okay, so computing limit. Okay, so saya nak masuk next subtopic 1.1.4 computing limit. Okay, so computing limits, we have several properties kat sini, tapi saya tak go through one by one lah, sebab you boleh refer yang recorded video. So cuma saya nak pergi yang properties number 1 and properties number 2 je. Okay, so for properties number 1, constant rule. So yang ni refer to constant. So any constant, for example, we have two. Constant tu boleh jadi letters ataupun numbers. Okay, so when limit x approach to 2, okay, so 2 is a constant ataupun dia numbers lah. Okay, so answer dia automatic is equal to 2. Okay, so ni rule number 1. And rule number 2, when x, so example dia when limit x approach to 2, so function dia is x cube. So to calculate values, you just substitute je x dia with 2, so dapat 2 to the power of 3, so equal to 8. Okay, so yang ni semua kita nak compute limit tanpa refer graph. Macam sebelum ni, example 6, example 5, example 3 tu, semua you compute limit tapi based on graph. Tapi without graph pun sebenarnya you boleh compute limit. Tak perlu use sketch graph untuk tengok limit tu. So kalau sebab tu kita ada properties ni, kalau you nak compute limit tu without using graph. So you boleh terus substitute je value. Okay. So kita pergi yang B. B is limits of polynomial. Okay. So based on the theorem, if f is a polynomial function and a is a real number, then limit x approach to a, fx is equal to fa. Okay. So kalau function f tu polynomial, so you nak tengok limit dia, you hanya substitute je value. Sebab tu dia ada fa kat sini. So you hanya substitute x tu with value of a. So you akan dapat terus answers. Okay. So saya ambil one example for a. Okay, so kita nak compute limit when x approach to 2. So yang ni tak perlu calculate yang one sided so kalau dia bagi function, you terus calculate je terus yang two sided. So no need to calculate yang 2 plus and 2 minus tu. Okay, so limit x approach to 2, so function is 5x cube plus 4. Okay, so you nak compute limit, senang je, you terus substitute je value x tu with 2. So 5 to power 3 plus 4. Okay, so you get the answer equal to 44. Okay, so answers for A is 44. B pun sama, you substitute value. So you have 0. And C, answers dia after you substitute, you have 5. Okay, so ni for example 7. Okay, so sampai for B sedang je lah sebab tu polynomial. So you boleh terus substitute je value. Okay, tapi untuk C, limits of rational function. So rational function ni also for fraction. So sekarang kita nak consider kalau function tu in terms of fraction. Dia different compared to example 7. Kalau you tengok example 7, dia bukan fraction. Okay, so kalau bukan fraction maknanya you terus substitute je value. Tapi kalau function tu in terms of fraction, dia ada several cases dia. Sebab bila fraction ni kita boleh consider you boleh dapat answers dia, contoh dia ada ancestry numbers, contoh answers dapat 1/2. Or dia boleh juga jadi 0/0. Or dia boleh jadi 1/0. Ni semua possible cases for fraction. Okay, sebab tu you tak boleh terus substitute value je. Dia ada beberapa case lah. Okay, so untuk yang C ni, for fraction, kita consider bila you substitute value answers dia in terms of 0/0. Or we call as indeterminate form. Okay, so we have two methods to solve when fraction tu in terms of 0/0. So the first method is using factorization. So technique dia, you need to factorize and cancel common factors in the numerator and denominator. And second method, you use rationalization technique. Okay, so rationalization techniques ni is used when a radical appears in the function by multiply with a suitable conjugate. So radical ni is set lah. Bentuk dia set ni ada dalam SEM 1 you belajar number system. Okay, so bila ada set, then you need to use the second method, rationalization. So method dia you need to multiply with a conjugate. So conjugate pun sama, definition of the conjugate semua you dah belajar masa semester 1. Okay, so you can refer to example 8. Okay, you need to determine the following limits. Okay, so kalau you tengok example 8 ni, dia different compared to example 7. Since example 8 ni, function dia in terms of fraction. So yang ini fraction, second example pun dia bagi in terms of fraction. Okay, so bila fraction, first step dia sama macam sebelum ni, you kena substitute value dulu. So you substitute value, sama macam yang example 7. Okay, Tapi bila you substitute value, contoh saya substitute value dia, you ada 2 power 2 minus 4. Substitute x dia with 2 So you have 2 minus 2. So answers dia you ada 0 over 0. Okay. So kalau 0 over 0, then you need to solve using two method. You kena choose lah. Method dia either you use factorization, or you use rationalization. Okay. So you nak determine which method yang suitable tu, so you kena tengok balik pada you punya function. So function dia tak involve set. Rationalization ni hanya untuk set je. So kalau function tak ada set, next, then you kena use ni lah, method factorization. So you just factor je. Okay, so limit x approach to 2. So saya factorkan, you have x minus 2, x plus 2, over with x minus 2. So you factor ni maknanya you kena, after you factor, dia mesti ada yang common factor. So that you can cancel lah. Macam ni common factor dia is x minus 2 dengan x minus 2. So after you cancel, you have limit x approach to 2. So final answer, final function dia, you have x plus 2. Okay. So you dah cancel the common factor. So remaining function ni terus you substitute x dia with 2. So 2 plus 2 equal to 4. Okay. Cuma cara you nak tulis limit tu, after you dah substitute value, contoh kat sini, ini dah substitute kan x dia with 2. So you tak perlu dah tulis limit. Okay, so limit ni, you write down the limit sebelum you substitute value. Okay, so after you dah substitute value, tak perlu tulis limit Okay, so terus buat 2 plus 2, so you can dapat equal to 4. Okay, so ni for the first technique. Sama juga B. So B pun kalau you substitute value, you also get 0 over 0. 2, 4. So ni 4. Okay, so value dia 4 ni saya silap So x approach to 4. So to 4 minus 8 over with 4 square minus 4 minus 12. So you have 0 over 0. So 0 over 0, next you use factorization technique. So you factor and then you cancel the common factor. So you left with 2 over s plus 3. Then substitute value, you have 2 over 7. Okay, so ni for example A. Next.
Madam.
Yeah.
Jawapan 2 over x plus 3 tu bukan bukan jadi negatif 2
Yang mana? Yang ni, now example 8 ke? Example
B.
8 yang A ke B?
B.
Yang B B dia, yang ni 4 dia bukan negatif 4 ni. Dia positif 4.
Oh, okay.
Positif
Okay.
4. So you punya notes sudah betul. Saya punya slide ni silap. So dia positif 4, so you akan dapat 2 over 7. Okay.
Okay, madam.
Okay. So yang ini for example 8. Ada lagi tak soalan? Ada?
Madam,
Ya?
Mas, kalau kita tengah buat jalan kerja nanti, yang kita gantikan substitute tu sama dengan 0 over 0 tu kena tulis juga ke kena tunjuk?
Tu you tunjuk lah. Tapi saya rasa tak ada markah sebenarnya. Tapi kalau you nak tunjuk pun better lah. Untuk you make sure, sebab you hanya pakai teknik ni, teknik factorization dengan rationalization ni, kalau you dapat answers dia 0 over 0 je. Kalau contoh you ada limit kan, contoh x approach to 1. Tapi function dia, contoh you ada x square minus 4 over with x minus 2. So bila you substitute value, you dapat 1 square minus 4 over with 1 minus 2. So you dapat 1 minus 4 dapat negatif 3 over negatif 1. So you dapat 3 kan? So kita x minus, so ni x minus 3 lah saya ambil. X minus 3, so ni pun x minus 1 minus 3. So nanti answers dia you akan dapat 3 over 2. Okay. So kalau you dapat answers fraction dia bukan 0 over 0, so you tak perlu solve using factorization dengan rationalization teknik ni. So makna answers dia you terus dapat tak perlu proceed lah, terus you dapat answer 3/2, so you boleh stop je. So untuk teknik factorization and rationalization ni dia spesifik bila you dapat fraction tu answer dia 0/0 je. So saya rasa better you tunjuk yang 0/0 ni kan, untuk you double check. Okay, boleh?
Boleh, thank you madam.
Okay. So yang ni kita baru method 1 factorization. Okay, so ni saya nak pergi yang method 2 untuk rationalization. Okay, so you can refer example 9. Okay, you need to determine the following limits. So first step dia macam biasa, you kena substitute dulu value. So you substitute value, you ada 1 minus 1 over with set 1 minus 1. So answer dia also 0/0. So bila 0/0, next you need to solve using rationalization technique. So sini you tak perlu pakai yang factorization sebab you punya function ni dia involve set. So dia ada set kat bawah ni. So kalau you nampak je ada set, lepas tu dia 0/0, so automatic you choose the second technique, rationalization technique. Okay, so rationalization technique you need to multiply with the conjugate. So x minus 1 over set x minus 1. So you multiply conjugate tu, you kena choose sebab you ada numerator and denominator kan. So you choose conjugate for the set lah. Mana term yang ada set. So conjugate dia is set x plus 1 over with set x plus 1. Okay. So you expand. So bila you nak expand, teknik dia, you hanya expand yang mana both side dia conjugate of each other yang ni. So yang atas ni, numerator, saya tak expand saya hanya copy je. Sebab nanti senang you nak cancel. So set x plus 1. So over with, so yang bawah ni, denominator, saya expand. Okay, so expand for conjugate of set. So you boleh refer balik yang notes in last semester. Dia ada yang shortcut dia kan. So shortcut dia biasa saya terus multiply yang first term with first term. So set x with set x, so you have x, and then second term with the second term. So negative 1 times with positive 1, so you have minus 1. Okay, so equal to limit x approach to 1. Okay, so you cancel x minus 1 dengan x minus 1. So you left with set x plus 1. Okay, so you dah simplify the equation. Next you substitute value. 1 plus 1, so answers dia equal to 2. Okay, so ini answers for A. Okay, for B pun sama. So for B, first you show dia 0/0. Okay, next you proceed with the rationalization technique. You multiply with the conjugate. So ni saya multiply with the conjugate. So you choose conjugate for the set. So conjugate dia is set 6 plus x plus 3 times over set 6 plus x plus 3. Okay, so ni sama juga. So untuk kat sini saya expand yang numerator je sebab dia conjugate of each other. So bila you expand, you boleh pakai shortcut method. Set 6 plus x times dengan set 6 plus x, so you dapat 6 plus x. Lepas tu negative 3 times 3, you ada negative 9. Okay, so yang numerator ni kalau you tengok saya tak expand, saya hanya copy je 3 minus x dengan set 6 plus x plus 3. Okay, so you dapat this one, lepas tu you kena factor lah sebab saya nak cancel yang ni. Okay, so answer dia is negative 1/6. Okay, so example 9 ni ada dalam recorded video kalau you nak tengok dia punya solution tu. Sama je macam ni. Okay, so ni for example 9. So saya nak proceed to example 10. Okay, so you refer example 10, you need to determine the following limits. Okay, so you substitute value over 3, 1 minus 3. Okay, so you ada 0/0. So 0/0. Next you factorkan dia. So you factor, you have ini. Okay, so factor for numerator is x plus 2 and x minus 1. And for denominator pun you factor sebab you nak cancel yang common factors tu. Okay, so you factor and next you can cancel x minus 1. Okay, so the function becomes x plus 2 over 3. So substitute value with x equal to 1. So answer dia is 1. Okay, so ini for example 10. A. Next for B. So kalau B, first step dia you substitute value 4 minus 4. So answer is 0 over 0. Next you boleh proceed lah, you solve dia. Since involve set, since the function involve set, so you need to multiply with the conjugate. So saya multiply with the conjugate. X approach to 4. So you have set x minus 2 over x minus 4. So conjugate for the set is set x plus 2 over set x plus 2. Okay. So equal to limit x approach to 4. So yang ni saya expand yang numerator. Sebab saya nak simplifikan yang set ni. So set x with set x. So you have x. And then negative 2 times with 2. So you have minus 4. So over with numerator saya copy. Set x plus 2. Okay. So equal to so you boleh cancel the common factor. So common factor is x minus 4 with x minus 4. Okay, so limit x approach to 4. So you have 1 over with set x plus 2. Okay. So after you simplifykan function, you substitute x with 4. So 1 over set 4 square root 4 plus 2. So answer still 1 over 4. Okay. So yang ini for limits of rational function. Okay. Ada soalan tak? For limits of rational function.
Tak ada madam.
Tak ada? Tak ada Okay. So saya nak masuk Okay, so tak apa, kita stop dulu kat sini. Example 11 tu saya akan continue you punya second lecture nanti. Okay. So second lecture nanti you boleh refer yang recorded video tu. Saya akan continue until example 21. Okay, tu untuk you punya next lecture. Next lecture you esok kan? Okay. So tu je lah untuk hari ni. Okay, so thank you semua. So kalau ada persoalan you boleh WhatsApp saya tanya.
Baik, madam.
Okay, madam.
Okay, madam.
Okay.
Okay.
Thank you, madam.
Thank you madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you.